electrical symbols and everything. So how many times have you guys ever run into an appliance, when you check the voltage is good, but you plug the appliance in, then all of a sudden the voltage is not there, or it's not the same voltage. Um, it's something called a voltage drop, and voltage is the same as electrical pressure. If you look at these two images, this is just a regular, they call it spigot or faucet, that's on the wall of your home that you hook your hose to. And here they're just showing the valve closed so no water can come out. I don't even know why this is blue, because if this was closed, there'd be no water on this side of it, unless the hose was connected. And then here, the valve is open and the water will flow. But one thing that's not illustrated in this exact image is that the way this valve is set up, there's a voltage drop or a pressure drop. And I'll first talk about water, then relate to voltage. So as the water's coming in, look at how big this pipe is here on the left-hand side. But as it goes through the valve, is this opening right here the same size as that opening? No. So the pressure on this side is going to, almost like a capillary tube in a refrigeration system, where it's a smaller pipe and it blocks the pressure. Hey Ali, it's a smaller pipe, so it blocks the pressure going through, so you do have some drop. Now, if I had a hose on the end of here with a spray gun or spray nozzle, if I stopped using it, the pressure on both sides of this valve would be the same, but as soon as I use it, the pressure coming out is going to be restricted to how big this opening is and lets the water flow. And again, I'm going to get into this voltage drop and the problem this tech had, but I want to relate it to water. So let's take a look at this. So what if the valve is not 100% closed or open, and you put a hose on it with a nozzle, and when the machine's off, the pressure on both sides of this valve are going to be the same when the hose is connected with the spray nozzle. But if you open up the spray nozzle, because the valve is not completely open like in the previous picture, the valve is so small, it's only letting a little bit of water come out as it's coming in. This is resistance like an electrical circuit. But in a voltage drop, you could have voltage to an appliance, and then you plug the appliance in, and then all of a sudden the voltage drops. And let's take a look at this here. So here's a stove, and I'm going to relate it. The technician calls me and says, Richard, I got a wall oven. And I checked the voltage in the outlet, so he checks L1 and L2 on the outlet, and he's got 240 volts. He goes over here to neutral, and L2 he has 120. And then he goes over here, and he puts it in line 1 and neutral, and he's got 120. So he says, oh, I got voltage, you know. And then when he plugs the appliance in, the voltage now dropped, and he only had about 120 volts between the two lines when the appliance is plugged in. And he was there with an electrician at that time too, because I don't know if the customer called and they showed up at the same time, whatever. But anyways, the voltage dropped. Well, a short circuit, like if you ran a wire from line 1 to line 2, electricity would just go like this and blow the circuit breaker. And that would be a voltage drop, because the electricity coming through that circuit would go in and out as fast as it can. It doesn't have any resistance, like all circuits, like a heating element, a light bulb, a water valve. They all have those like kinks in the hoses that slow it down. So he's like, well, how do I explain that the appliance is not causing this? And I said, because the appliance doesn't create the electricity. Electricity is in the wall. If you plug the appliance in and the voltage drops, what would cause that? Well, let's go back a second to the previous image. What caused the drop in pressure here was resistance in the hose, not resistance in the appliance. So he's like, well, what? Guy didn't open up the wall and put a water valve in there or a resistor in there, so why is the resistance happening? So this could be happening to multiple of things. The outlet itself, inside the outlet, could have bad connection, loose, burnt connection. The wires that are screwed onto the other side of this outlet could also be burnt or loose. And it could even go as far as the circuit breaker panel. I've seen breakers, especially if some houses had aluminum wiring and the wiring breaks down, and they had to replace the entire panel in someone's home because of the aluminum wiring. But the breaker, where it clipped onto the bus bar going down the middle, all the little parts of some of these breakers were burnt. So when it's off, you have full pressure, but as soon as it starts running, the burnt part is not allowing enough water or enough electricity to flow through, so you get a voltage drop. Okay, so that's what was happening to this guy's stove, but he couldn't understand. Okay, I understand you're telling me it drops when I plug it in, but how is it happening, or what is happening? And that's what that was. So guys, this was just something different from what actual today's class was, but I wanted to